Okay, so before you factor tractor, so I know a lot of times right off the bat, like all those easy ones, we were just like, what multiplies to this, what adds to this, and we like wrote our answer down, right? So actually, you should always look for a GCF first and then look to factor further if possible, okay? So when you see one like this, the first thing we want to look for is a GCF, a greatest common factor. That is the first thing we learned how to factor in this class, was just a GCF, okay? So you look at the A's, right? And how many A's are common to each term? Yep, we can take out A squared. Then we look at the X's. How many X's are common to each term? X cubed. And then M's, how many are common? Good. Now we have 3 things left inside. We took out A squared from this, so what is left? A. We took out the X cubed from the X to the 4th. How many are left? Just one of them. And we took out this M squared, so we don't need to write it down, plus, okay, we took out an A squared. That's all of it, all right? Then we took out 3 X's. How many are left? 2. And then we took out 2 M's. How many are left? 1. Minus, okay, we took out 2 A's. How many are left? We took out all 3 X's, and we took out 2 M's. Okay. And then you would look if this needs to factor again, which it does not. So sometimes what's left is like one of the trinomials that is factorable. All right, this one is not. So you're just done. It literally only has a GCF. Let's try another one. Oh, neat. All right, what number is common and can divide out of 6, 2, and 4? Good, we can take out a 2. How many A's? 3, okay. How many X's? 2, agreed. Now we have to be able to multiply back to get all 3 things, okay? So you're doing 2 times what would give me 6? 3, good. We took out 3 of those 4 A's, so 1 is left. We took out all the X's, all right? Plus, we took out a 2, we took out all the A's, and we took out 2 of the X's, so there's 1 left, all right? And then 2 times what would give me 4? Okay, we took out 3 of the A's, so 1 is left, and we took out 2 of the X's, so 1 is left. This is another one that does not factor any further, okay? We don't have like A squared plus something A plus a number, okay? So we're done. It's just a GCF. Now let's do one that has both steps, okay? Both steps. So they're not going to tell you, look for a GCF first. You just have to recognize that there is a GCF, okay? What's common in each one of these terms? I don't know why I have an equal sign here. I would just take out an X, okay? That leaves me with X squared plus 6X plus 5. And again, they're not going to say, hey, check and see if it factors. You just have to check and see if it factors, right? So does anything multiply to 5, 2 numbers, and add to 6? 5 and 1, okay? The only 2 numbers that multiply to 5 are 5 and 1. And yes, those would also add to 6. So you leave the X in front, and you do the 2 parentheses factor tractor, X and X. And again, they have to multiply to 5 and add to 6, which are 5 and 1. All right, and we leave our solution with that X in front. So be sure you continue to write your GCF just in front of your 2 factors. All right. Okay, this one is really important, and for some reason people are really bad at this one, so write this down. We have negative x squared minus x plus 42. Okay, there's not really a GCF, like a normal, like there's nothing that looks common. The thing that's weird about this one is the negative in front of x squared, okay? You have to factor it out of all the terms, almost like it's a GCF, okay? So I'm going to take out a negative. It's really just a -1, but it pulls out from all 3 terms. All 3 terms, okay? Be sure you take it out from all 3 terms. So I take out a negative, which changes this to positive. I take out a negative from the next term as well, which changes this to positive. And I take out a negative from the next term as well, which changes it to negative. Okay, why does this work? If you were to multiply this back through, you would get that, right? Okay, now you're allowed to factor. You cannot factor until you take the negative out. You can't factor when there's a negative in front of x squared, okay? So just always factor it out like this. Okay, now I can factor tractor what multiplies to negative 42 and adds to positive 1. I agree, 7 and 6. Okay, in order to get a positive 1, which one has to be positive? 7. We have to add to positive 1. Does the negative in front matter when you're factoring this part? No. So like ignore the negative. Once you take the negative out, has to add to 1, positive 1. So it has to be 7 and negative 6. That'll multiply to negative 42, add to positive 1. All right, so do not skip this step. Please always show 2 steps when there is a negative sign in the front. Everyone just really wants to write the answer down. Okay, you have to factor the negative out. Okay, negative 4x cubed minus 28x squared minus 48x. All right, what number can divide into all those numbers? 4 would be even better. Okay, 4 can come out. And what variable is common to all those terms? X. And do we need to take a negative out? Yes. When there is a negative in front of the highest exponent, you need to take it out. Okay, so I am going to take out a negative 4x. That's my GCF. All right, the GCF will be negative 4x. When it comes out from this first term, what do you guys think is left over? X squared. Okay, when it comes out of the second term, we have to be able to multiply back to get negative 28x squared. What sign should I have here? Plus. And then 4 times what is 28? And I took out one of the x's, okay? And again, we took the negative out, so my sign needs to change. Or a negative times a positive would give me a negative here. 4 times what is 48? 12. And we took out the x. Okay, and now does this factor tractor again, you guys? Yes, it sure does. What multiplies to 12 and adds to 7? Positive 4, positive 3. Okay. This one looks fun. Okay. What number comes out of all of those? I agree with you. 16 goes into 48 and 160. Okay, how about a squared? How many of those, or sorry, how many a's can come out? 2 of them. Okay, how many b's are common? 1 of them. All right, cool. And the x's, you guys, there's not an x on the third term, so we can't take any x's out, right? So I take out 16a squared b. What's left? X squared. Great job. Okay, and then 16 times what is 48? 3. All right, and it would be a negative 3 because I didn't take a negative out. It stays negative. Okay, I took out the a squared b, so I have an x here. And then 16 times what is 160? 10. And I took out the a squared b. So the GCF is 16a squared b. And now I have to factor tractor this lovely trinomial because it still factors. What multiplies to negative 10 and adds to negative 3? Good. Negative 5, positive 2 would add to negative 3, multiply to negative 10. And that would be my final answer. Oh, there's more. Oh, yay. I know. Sorry. Okay. Subscripted variables. I know. Go ahead and write this down. You guys are so sad. Okay. This is really easy, okay, you guys? It's NQ and NN. When you have this subscripted variable, this usually means like number of quarters, number of nickels, all right? You can solve this either substitution or elimination. The NQ is one variable, okay? The NN is one variable. It's just a subscript, like helping label it, but it's one variable. Elimination, in my opinion, is the fastest, all right? So let's say I want to either cancel the NQs or the NNs. Doesn't matter. Probably the NNs are easier because this is a smaller number. So if I want to cancel the NNs and do elimination, what should I multiply this by? Yep, just 6, because that'll give me a negative 6 NN, and this is a positive 6 NN. All right, so I have 24 NQ plus 6 NN equals 360. And right here, I'm going to multiply. This will give me 6nq minus 6nn equals 30. Be sure you multiply all the way across. All right, add down. What's 24nq plus 6nq? 30nq. You just treat it as a variable, okay? These cancel schmancel. And then I have 360 plus 30 is 390. Divide both sides by 30 right here. The zeros will cancel. 3 goes into 3 once, 3 goes into 9, 13 times. NQ is 13. A lot of times that stands for like number of quarters, okay? We'll be doing the nickel, dime, quarter problem soon. Now we can plug this in somewhere. This equation is probably the easiest. If NQ is 13, right, I can subtract 13 from both sides right here. Negative NN is equal to negative 8. Divide by a negative 1, and so NN is equal to positive 8. You don't have to write these problems as coordinates. You know how usually we get x comma y? These don't represent a coordinate point. We're like talking about a number of something, so you just leave it like that. All right, that's it. That's subscripted variables. Yes? Oh, the subscript? So you still know it's one variable, I guess. So it usually just represents like number of nickels. I don't know why. If you wrote it as NN, that would maybe be n squared. You know what I mean? It's not like multiplying together.